Hey guys, this is Pratik and you're watching Technocrat. When we listen to people discussing about the quality of audio, we often see that they refer to digital and analog audio. Analog audio is the traditional way of storing audio, and not until 20 to 30 years ago, digital audio came into play. But how is analog audio different from digital audio? In analog audio, the audio is stored as it is, but in digital audio, the audio is sampled in both the time and amplitude axis. So in digital audio, the audio is stored in a form of digits or in the binary form or ones or zeros. Let us see why we have moved to digital audio and let us see how it has a superior quality over analog audio. Basically, audio is a physical parameter. It means that it has infinite number of values. At every particular instant of time, you have an amplitude value, and that amplitude values are also infinite in number. Any computer or a digital system in this world will only be able to record, transmit, process and store finite amount of data. Even a supercomputer will not be able to deal with infinite amount of data. So for you to bring this infinite amount of analog data to a finite amount of digital data, you need to have a few trade-offs, and at the same time you also need to have a consideration of the required quality and also the amount of storage that this finite data would occupy on your disk. Breaking down the time axis to small intervals of time is called as sampling, and breaking down the amplitude axis to different levels of amplitude is called as digitization. So how frequently should you sample the audio, or how many amplitude levels can you have in the audio? It purely depends on your application, and it purely depends also on the amount of space that you can allocate for each audio file. Just because everyone doesn't come up with their own sampling rate and systems become incompatible, there are few industry standards. We have 8 kHz, 32 kHz, 44.1 kHz, 48 kHz, 96 kHz, 88.2 kHz and 192 kHz. 8 kHz is used somewhere in the old telephone lines, and 44.1 kHz and 48 kHz is the sampling rate that we see most often. The higher sampling rates such as 88.2 kHz, 96 kHz and 192 kHz are used in studio level equipment. They require a very superior audio quality. Now that you have broken down this infinite time axis into few finite instances of time, you also find corresponding amplitude values. These amplitude values are approximated to few levels of amplitudes. So let's see how this amplitude axis is broken down into small pieces. Basically, the amplitude axis is broken down in steps or in levels of amplitudes. It means that any amplitude that is between two levels is approximated to the nearest level. As we are trying to convert analog audio to digital audio, it means that the final bit stream can only have zeros and ones. So the number of amplitude levels can only be parts of 2. Say suppose you want to encode each amplitude value at this time instant in 8 bits, then you'll have to break down this amplitude axis into 256 levels. And say suppose you want to encode it in a 10-bit system, then you'll need 1024 amplitude levels. This scheme of encoding is called as PCM or pulse code modulation. Every level of amplitude is assigned a permutation of zeros and ones. Say suppose you take an 8-bit system, then you have 8 slots in which you can fit either a 0 or 1. So 2 power 8 becomes 256. Even the bit depths have few industry standards like 16-bit, 20-bit, 24-bit and 32-bit. A 16-bit audio system can have 65,000 audio amplitude levels, and a system that is encoded at 24-bit can have audio levels as high as 16 million. Now it is clearly understood that higher the sampling rate, the better the quality, and higher the bit depth, the better the quality of the audio. So there has to be a trade-off. If analog audio has infinite number of amplitude levels at each and every instant of time, then what would be the minimum number of samples that can be taken on the time axis? This is where the Nyquist theorem comes in. Nyquist in his sampling theorem has proposed that the minimum sampling rate has to be double or more than that of the maximum occurring frequency in any audio waveform. So as we all know, the human audible frequency is 20 kHz and double of that is 40 kHz. So 44.1 kHz is just 4.1 kHz more than what Nyquist theorem proposes. This is because just to avoid few artifacts and aliasing effects. We have seen what is sampling rate, we have also seen what is bit depth. So you might have also heard about something called the bitrate. Bitrate is nothing but the amount of bits that it takes to store 1 second of audio clip. Both sampling rate and bit depth combinedly contribute to this bitrate. We most commonly come across bitrates like 128 kilobits per second and 320 kilobits per second. It means nothing but 1 second of audio clip is taking 128 kilobits of disk space to store. This video is part of the series Understanding Audio. I've also made few other good videos like how noise cancellation works, how audio jack works, how a microphone and a speaker works, what are the different kinds of file formats. Do watch all these videos to have a better understanding of audio. Subscribe to Technocrat if you haven't yet subscribed, and do turn on notifications to never miss an update. I'm glad that you wanted to learn something new today, and I hope that you have learned something new from this video. Always believe in science and make the best possible use of technology. Thanks for watching. Bye bye.